I'm Moe Tanabian, and this is Anil Gorthy. We're from a team in San Jose, which we're called Smart Things Innovation Lab. And our basically mission is to develop smart connected devices and environments. The SDK that Anil is going to introduce is LifeConnect, and it's, have you ever seen AirPlay?
Are used?
It's a similar concept, but not just for TV, for everything. You can basically detect and connect to a lot of devices with one tap and one user action. So we do, Anil is going to walk us through. Just out of curiosity, how many of you are involved with smart home and that type of stuff? One here. What type of smart home do you work on? What?
Research and expert
in the area of smart home. Anyone else? How about you, sir? Connected devices? What type of devices?
routers, switches, sockets, sensors.
Okay. So it's a really smart home solution then.
Yeah, it walks like a smart home, so.
Okay, so how about walking? All right. So I'm going to pass it on to Anil, and Anil is going to walk us through the SDK. But appreciate you guys sticking around for the last kind of hour of the last day.
Thank you, Bo. Thank you very much. We'll try and keep this super brief so that I know that I'm standing between the party afterwards and the session, so I'll be very quick. Like Mo mentioned, I work on smart home solutions. This is one of the videos that we want to get you started to see how super simple. Oh, supposed to be audio. Can we get audio, please? Sure. I can just wave at her and she'll listen. Great, thank you. That's how simple we want our smart home devices to be. Just a quick show of hands, how many of you actually use smart home devices? Not you, Sean. What device do you use? Oh, okay, switch over to. Okay, all right. Hopefully we'll have an answer for you soon. So what we are looking at is how super simple smart home setup of these devices can be, how people can quickly get on, connect to their devices, add them to the Wi-Fi network, and then control them immediately. That's something that we are really striving towards, and then making that happen is a reality that we are working towards. Why did we come up with LifeConnect? There are already various apps and solutions out there that already enable you to quickly connect your devices to the network and control them. But as you would imagine, this is a quick rendering of how many different smart home solutions are there or smart home devices are there. Each obviously comes with its own cloud-based solution. Interfaces obviously need their own app to include and add them. And if you want to control them, then you need a hub or a bridge-like device for something like a Zigbee or a Z-Wave-like device. And that's the current state. There is cloud-to-cloud interfaces, interaction that enables communication across multiple devices, but essentially that is the current state. And it's working. It's a lot of people that are used to DIY, do-it-yourself, tech-savvy people that are enabled to do this, and they're making it work. What we are trying to focus is on 3 core functionalities. One is how quickly can we discover devices as soon as you plug them in. You saw in the video, the lady actually stick in that VMO switch, And she was able to immediately discover that device and then start controlling that. It should be that simple and like 1 or 2 clicks, not worry about which particular model of the device it is, what manufacturer it is, and who am I connecting to. That's one of our goals, is to quickly discover devices that are in your network. And then after you connect the device, you want to control them with a basic UI. Currently, you need to have your own installed app for each of the devices that you have, say 10 different devices that you have. You have to install, download each one of them, and then you can control each of them independently. But what we want to show is the most basic UI that you can control. If it's a Wemo switch, then probably it's just an on and off. If it's a Philips Hue, then on and off again, but adjusting the hue. Next is increasing the brightness or lowering the brightness. So those are the most common actions that you want to perform. We're not here to replace the native app that either of these manufacturers are building, but we want to just show the most basic controls. That's the dynamic control UI. And obviously, like orchestration, SmartThings has talked about how we can create lots of different scenarios to say that I'm returning home, and hence these are the 5 devices that I want to control. That's exactly what we want to do as well. So similarly, you can put together all these devices that are connected in your home and then make them perform certain actions for you. So that's orchestration. And again, like you saw in that video, we want to enable these devices so that they already are discoverable. Each of them speak either UPnP, MDNS, they're already advertising. It's just that we are doing a lot of work in the background to make sure that you can quickly discover these devices and then show the most basic information about the device. And then we use that information to send, like over here, I'm able to detect there are multiple devices in my home. And I send that most basic information that each of these devices advertises in terms of either the model number or the device type. And then we use what we call a device definition language, which I'll get to in a second, that enables me to send me more information about what that device is, what its capabilities are, how you can control that device, what APIs you need to make those actions perform. That is what the DDL is going to send. And then, so again, like I mentioned, we support Wi-Fi, Bluetooth, BLE. I don't know how many of you heard, but there is something called Web Bluetooth API as well. Firefox OS started supporting it, but even Google is starting to support it. But that also enables us to control devices that are Bluetooth enabled outside of the home as well. And of course, if you need a Zigbee or a Z-Wave, you need a hub or a bridge, just like Philips Hue or a SmartThings hub. And we want to be able to ensure that users can control these devices across multiple devices. You just don't have one device. People have a gear, people have a phone, tablet, TV, what have you. We want to be able to present that dynamic control UI across multiple devices that users have in their home. Again, like I said, we are going to only show the most basic controls that you need to access each of these devices. And hence, for Nest, for example, you want to turn on or off, adjust the thermostat, or set the mode to either AC or heat. So those are the basic controls that we want to be able to show to users. Again, if it's a smart TV, then what do you need? You want to turn it on or off, set a channel or the source to a particular number, increase, decrease the volume. So those are all coming from the DDL, which will skip the slide here, but this is orchestration that we talked about. Imagine this scenario where this guy right here is leaving home, and he has multiple of these devices without actually having to go and switch off each one of them. We just create an orchestration scenario where that light, the thermostat adjusts automatically so that it's not burning your electricity all the time while you're not in home. There is a vacuum cleaner, there's a TV. So each of these could just be part of an orchestration where I can control them together. So right here is a TV. So I create an orchestration that turns off my TV. Next orchestration would be to switch off the light in the home when I'm gone. Adjusting the thermostat. I want to increase the temperature while I'm not in the home. And then obviously let the Roomba or the robo vacuum cleaner start cleaning the home while I'm away and keep the house clean when I return. So that is about creating orchestration scenarios. Because we have access to all the devices that are in the home, it's easy for us to create an orchestration scenario like that. How are we able to do all of that? So this is a quick walkthrough of how we are able to connect to a VMO device. So you can see the first time we have what we call a LifeConnect app or a framework that will be baked into the Android device. First launch, and then you start searching for devices, at which point we're sending out discovery packets, which in this case is SSTP, which UPnP uses. Similarly, MDNS also sends out this packet. And then the device returns its most basic information along with all the services or the capabilities that it can perform. So we read that, and then we send that information. We just look for the name and the model number of that device, send that information to what we're calling a LifeConnect cloud that then returns the device's core capabilities, which is the device definition language, the actions, the UI assets or icons that I need to display that UI dynamically as I look at different devices. And then this is how the basic information about that device is informed, because the device advertises itself with that exact name. It's a VMO inside switch versus a VMO switch. They're two different devices, but I get that exact information from the device when it advertises. And hence, I'm able to display that card. And then I can, obviously, you'll have more than one device in the home, so you can give it a nickname and associate it with a room so that you know which one you're controlling, like living room 1, but I have VMO switch 1 and up to 5. And then that's where it's connected. And then you get the most basic controls, which in this case is just on and off for a VMO switch. That's how simple it should be in terms of unboxing a VMO switch, plugging it into the wall socket, and then just having it connect to the Wi-Fi network. So what is that is powering all of this information? As I mentioned, we have what we're calling a LifeConnect SDK/framework that will be baked into the device, and hence it's constantly looking. It's not another app that you want to launch or install, but it's something that is sitting in the background as a service and searching and looking for new devices. As you stick in new devices into the home, it will pop up and say, hey, you have a new device, do you want to add it? And that's coming partly from all the services. We have the DDL, the device definition language, is something that we're opening up to developers as well, and independent developers as well, to actually stick in the device's information into the database so that people can start building device definition languages. So I'll talk about that in detail later, but we will get all that information from the device manufacturers as well as independent developers regarding the devices, what capabilities it has, what controls it supports. And then we will do our own certification in terms of adding the UI controls or the URLs for the UI controls. But this is the current architecture. For us, it doesn't matter what type of devices you have, what language it speaks. But obviously, if you need a ZigBee or Z-Wave, there is a hub. But what form or shape that takes is not something that we are concerned about, as long as it's speaking an IP-based language, which in this case is Wi-Fi. So that's the entire architecture for us. We have that database of DDLs submitted by manufacturers as well as vendors into the site that enables us to perform all these actions. And then once the DDL is submitted, it provides information about what the device capabilities are, but we need to do our own validation in terms of like verifying the JSON in terms of compliance as well as for correctness. But I also need to use and provide the DDL and update it with the actual assets that I need to provide for a certain action like a VMO, an on and off, or a Philips Hue, where I need to increase, decrease the brightness. All of that information is based in our asset library. And based on what specific type of device it is, it doesn't have to be the manufacturer, but just based on the device type. Whether it's a light, then we'll provide a brightness icon or an asset that enables them to do that. So all of that happens offline, and once that is approved, then the DDL is submitted through the process and it's certified. At which point, when the user discovers that device, then, for example, in this case, we're using Nest, we're able to display all those controls based on the process that I just described in terms of adding that controls to the UI. as well as showing how to control that particular action on the nest itself. And here's where I'll go into a little detail into what the device definition language means to us. It consists of 3 core components. It's just basic device info, which means that what actions, what is the device model, manufacturer name, vendor name, model number, things like that. And then the protocols and actions talk about, like I said, what protocols does it support? Does it have Wi-Fi, Bluetooth, and BLE? And hence, based on what protocols it supports, it gives me the power to understand what actions I can use based on the controls. If I'm sharing data, then obviously I don't want to do it or Bluetooth or BLE. Then I'll switch over to Wi-Fi. That sort of capability is present through the protocols and actions. Similarly, UI and controls, I talked to you guys about that in terms of showing what icons and assets that I need to display based on the actions that I'm performing. And again, the certification process makes sure that all of that is compliant with our standards and the correctness of the assets and whatnot. So this is the basic device info. For us, Belkin, that's a device UI ID that actually advertises as Insight and the number, and then the device name is Moe Insight 803. And then we send that information to the server to get this entire DDL as well as the icon for that Moe switch itself, Insight switch. And sorry for this small print, but there's a ton of information here. For actions, we want to show the most basic controls and hence not replace the native app that each of these manufacturers are providing. So that's why we broke our actions into core and secondary. By core are something that LifeConnect knows how to handle and can perform actions, and hence you will see in the next slide the UI controls corresponding to that. Secondary are something that we know they exist, but we don't want to handle that, at which point we want to pass it on to the native app developers like the Philips Hue, the Moe switch guys, or the Nest to perform those actions. And then here's the UI controls that, again, this is all submitted by the device manufacturers as well as the independent developers. And then we take all of this information. I'll talk you through. Yeah, this is the workflow where once the DDL is submitted, how we look at it, what changes we make, and what is the certification process. How do I go about submitting the DDL? We created a developer portal where we're encouraging manufacturers and independent developers to submit their device definitions to us and publish that DDL. And as many of you would know, the largest IR database that Logitech built is not essentially built by them. It's from the independent developers that actually created that. And in the same way, we are hoping that the DDL becomes that de facto, or where developers can submit all their device information into our database and hence can be used and integrated with other smart home platforms. And then you can start LifeConnect starting to discover these devices. So this is a portal. I'll quickly walk you through that. We're taking a couple of paths. One is talking with SHP. Probably some of you have attended the session with smart home platform that Samsung HQ team is developing. So one of our go-to-market strategies is to work with them to integrate our LifeConnect SDK so that, one, we ease the process of discovering and showing the most basic controls. And hence, I think SHP is also going to work with SmartThings to make that integration happen. But we're staying at the level where we can discover devices quickly and then show the most basic controls, and then SmartThings can take it from there. Any questions that I can help answer?
How rigorous is the process to get a DDL for something like that integrated so that they can try it out?
Sure. As you go through the certification process here, that slide is not there. But it's very basic in terms of the certification. What we are looking for is, one, just that the JSON response that the end device, the client device is requesting, is well-formed, the JSON. And then showing the most basic controls or actions. That's all we need from the end device manufacturer or the developer that's providing the sensor or the Raspberry Pi. That's all we look for. Not at this time. Yeah. Sean. Right, exactly. So that's one of the things I think Sean and I talked about, where we can discover devices using UPnP, MDNS, but then the next part comes about how easily can I actually put it on the Wi-Fi network. A Vimo or a Philips Hue advertises itself as a soft AP. But we want to work with manufacturers and vendors to actually able to stick in a LifeConnect agent on their devices that enables us to transfer the Wi-Fi credentials from the source device to the end consumer device. And hence, the agent that is there will read the Wi-Fi credentials from the source device, which in our case is a Samsung device, that enables us to send those credentials, and then the agent knows how to take those credentials and connect itself to the network. That's something where we want to work with manufacturers to enable that. And hence, we're calling and speaking to various manufacturers. So when, yeah, sure. Right. No, absolutely. So when we mentioned about the SDK, that's what we want to give out as. One part is about discovering each of these devices. The other part is also saying that, hey, from the source device that has currently smart Samsung devices, we can transfer those credentials, but there is the SDK part that you as a manufacturer need to stick into your device. That enables that end-to-end connectivity. So yes, it's not clearly mentioned, but as part of the discovery and control, we're baking it end-to-end, because it's not just about discovery. We need to complete the picture of pairing it and connecting it to the network. Yeah, but the SDK enables us to do that. Soft AP? Yeah. Right. Yeah. Right. Yeah, that's where we need to install the native app, right, to actually get them to that mode and then transfer the Wi-Fi credentials. And hence, we want to work with manufacturers to, have that capability built in. So either whether soft AP or Wi-Fi direct mode that enables us to send those, discover the device, but also send the credentials over to them to connect them to the network. Any other questions? All right. With that, I'll let you get back to your, I think the next party is at 8 o'clock or so. But thank you so much for sticking around and watching our session.